Well, hello everyone and welcome to my presentation. And yes, this happens a lot. I mean, I have 10 letters last name and it's kind of yeah, tricky. So today I'm going to talk about building scalable APIs in Python with ZMQ and JSON RPC. So let's start with the definition. So what is an actual API? So we all know what it is, we use it every day, and it stands for Application Programming Interface, and it's, as Wikipedia says, a set of clearly defined methods of communication between various software components. So actually what that is, I mean, if you take a look at this picture, API helps left side and right side communicate by providing an interface between them that is kind of standardized. So why do we actually need API? Well, API simplifies programming. And how? It hides the implementation details. We've heard this so many times, but do we actually know what that means? I mean, they say that when you use the API that you cannot see the implementation of the software that provides the API, and in Python that's not true. So actually you can see everything, but actually what I would say is that you don't care about the actual implementation. What you need to care and what you actually need to know is only that, the interface. So why is this good for? I mean, it allows us to change the software that we provide through an API to completely change the implementation of that software without affecting the clients. And later on, I'm going to tell you exactly how that helps us. So we can also see an API as a tool that helps a programmer to communicate intent to the computer. So yeah, what does scalable actually mean? I mean, I tried to read like a dozen blogs that will help me clarify this. Whenever I type scalable APIs, the only part where the scalable actually is mentioned is in the title. So so what I do, I mean, then I decide to invent my own definition. So in the context of APIs, when I say scalable, I mean like you can freely add more functions and more clients to your API without breaking the code. So how to build an API? So actually, there are a lot of ways. If you actually have a software that people use and you don't have an API, first thing you have to do is get the requirements. So you ask them, why do you need this API? What this API can do for you? Usually people will start talking nonsense. I mean, a few days ago we had a case where we asked, actually our QA team asked us to provide them a simple function. So we said with them and said, okay, what this function need to do for you? And instead of giving you like spec, they tried to provide you an actual implementation. And what we said was like, no. Tell us what you need and we will care about the implementation, not you. So in the ideal way, or ideal case, when building API is to start with a short spec. Large spec is good, but actually it's sometimes it just turns out to be a really waste of time because things change rapidly in software development today. So if you have a large spec, that means that you have lost most of the time discussing about it, but you did nothing to implement the API. So if you have a short spec, it's easy to modify, and you can also immediately start creating small examples. You can start using your API to create prototypes. Actually, this means that API is really not implemented yet, but you're actually using the interface and you can play with it and you can see how that actually looks like. So when you have this, you can always iteratively improve. So you again gather the same group of people and say, okay, we have this, does this help? And they will say no. And then you'll say, okay, let's try to figure something out. Let's find a solution for you. So after you do that, I mean, the most important thing here is to document your API religiously. So I had an opportunity to use this really great front end for LLVM, and I'm not going to name him because what I needed to do is write simple source-to-source transformer. So I would take like C code, I will parse that, and I would try to create a small tool that will transform that C code into something else. And the tool works marvelously. I mean, it's really good, but the documentation is not existing. So I lost like a month to figure out that what I wanted to do, actually, I can't do with that software. So please document your API. So what are some characteristics of good API? I mean, it's obvious. Good API is easy to learn. It's easy to use and easy to extend. So when someone uses your API, it's like they can immediately start in like 50 minutes, they have something that works. That's ideal, but sometimes that's not just the case. And good API is consistent. So when you name things, try to keep those. I mean, there's good example. Like you have two methods. One is called remove, one is called delete, and you have one add method. So what's the difference between remove and delete? I mean, it's not consistent. So, and I saw the APIs where both method exists, and you simply don't know which to use. So recently we had a really bad problem. So most of our software was written in Python 2.7, and the actual architecture of our software was something like this. So we had a large software, and we had an API that was kind of integrated into that software. So they were really tightly coupled, which means that we cannot change anything underneath the API because it will directly affect the client. So, and as Mecca said, the Python 2.7 will soon be like kicked out. So we have to do something to change how our software works, but without affecting the client's code. So, and also one of the requests from the users was, hey, but your API is really good, but can we use it from like a different programming language? And at the time we would say no, but now we have a solution that works there. So how do we solve this problem? So we decided to split the API into two parts. So one part of the API would be like server side, the side that collects the requests, and then when it collects the request, it will contact the actual software, they will communicate, and then return the answer. So why is it important for us to have language agnostic server side? Because to provide a lot of clients, we would also have to provide a lot of server sides, and we don't want to do that. So what we did is split into server and client, where client side is a specific for each language. And I'll show you actual picture how that works. So this is how we did it. We have a control center that's like the main application that we have, which has the server side, and this is the client side. So as you can see, this here is a remote call. That's the only thing that is remote. And we use JSON RPC as a standard to communicate with our server side and the client side. So this means that client can be implemented in any language as long as it respects the boundaries of the JSON RPC specification. So this solution actually works for us, but as you can see, there's a problem. So the right side can scale indefinitely. So you can have as many languages as you want, but the left side actually cannot scale so far. And the good thing is that we don't need it to scale. So because we have a desktop app where you can only have one client per application. So actually, as I said, this thing can improve. So how? You can, yeah, this is a scary graph. So the right side is still the client side. As you can see, you can have multiple versions of the clients. And you can have a load balancer or API gateway that will somehow create, like, you all use Google and you have single sign-on. So this acts like something like that. So API allows clients to only know about this one, but not about these other implementations. So actually that's it. We can scale this side indefinitely and also this side, but we still have a problem, right? This thing here actually cannot scale that much because it is shared between all of these. But luckily we don't need it so far, so yeah, that's it. So he asked me this to have a really short presentation, so that's it. Any questions? He didn't see it. I'll do it again.
So where's the ZMQ?
Yeah. So ZMQ serves as a transport layer between these sides. So both of these sides use ZMQ sockets to transport the messages, and we use JSON RPC as a format that ZMQ uses to send these messages. So basically, what you have here is a request. Yeah, a request socket. No, here the request socket, and here's the response. So ZMQ moves the message from the client to the server and back. So it's actually here, and in this case, we'll have it on both sides. So.
And one more. Do you know if ZMQ is maintained by somebody who is not the author? Unfortunately, he has a terminal illness.
Yeah, I didn't know that. Yeah, that's a bad thing because it's really good library, and so yeah, that's it.